I am Rajendra Bade, and in this video we'll continue with the topic orthographic projections. We are going to solve some more problems on orthographic projections. Hello, I am Rajendra Bade, and in this video we'll continue with the topic orthographic projections. We are going to solve some more problems on orthographic projections in this video. Now read the problem. The pictorial view of a machine part is shown in following figure. Pictorial view, that is three-dimensional view. Draw front view from X, that is from this direction. Top view and insert at least 6 dimensions. The question was asked in Mumbai University May 2018 exam. Okay. Now when you look at this diagram, this object, in seconds you can identify 3 portions of the object. There is a cylinder at top, there is a base plate, and there is a thin 12 mm thick plate connecting these two parts. There is a cylinder at top, there is a base plate, and these two parts are connected by a thin plate. So we are going to complete this diagram part by part. You will understand. Now, first thing what you are going to do is identify orientation of length axis, width axis and height axis. These are the 3 axes. Of course, vertical axis is height axis, and now we'll have to decide out of these 2 axes which are at an angle 30 degrees with horizontal. Parallel to this arrow, that is width axis, and of course the third axis is length axis. Now we'll able to identify overall length, width and height axis. Focus on all dimensions which are parallel to length axis. So in this orientation, at top we can see from extreme left end of the object to extreme right end, no, up to the center of the cylinder, the dimension is given 100 mm, and extreme right edge of the object is curved edge. So we'll have to add a radius of this curved edge, and this curved edge has diameter 36. So radius is 18. So 100 mm plus 18, extreme left to extreme right. That is overall length of the object, and it is 118 mm. So we have identified length 118 mm. Now overall width from front, you know, with reference to this position of observer, this is front side and this is back side. So from front to back, width it is given, watch here, extreme front surface to extreme back side surface, length is given 75 mm. So overall width of the object is 75 mm. Now check dimension vertically. So parallel to height axis, 63 mm is mentioned here. There are many other dimensions which are parallel to height axis. But remember, we need dimension from extreme base to the top. And from base surface to the top surface of the object, already height is given 63. So we know height of the object. So this is how we have identified overall dimensions. Now draw front view rectangle. Remember, in front view you get length horizontally and height vertically. So measure 118 mm horizontally and 63 mm vertically and complete a rectangular box. So this box is made by thin lines. Remember, right now we are not drawing edges of the object. It's just a rectangular block which envelopes the front view. Now overall length of the object is 118. Now we'll draw a rectangular block in the top view. In the top view we can see length 118 mm horizontally and width vertically. How much is width of the object? 75 mm. Now don't measure length 118 mm independently. Project it from front view to top view. So this is how length 118 millimeters in the top view And now leave some space from this rectangle and then measure width 75 millimeters vertically. In the top view, width appears vertically and then complete the rectangle. So this is a rectangular block in the top view. Now listen, in this problem, we are not asked to draw side view. So we are not going to construct side view. So front view and top view we are going to draw here. Now one very important thing, check here, left side and right side of this object are not similar. Top bottom are not similar, but front side and back side are similar. So in a glance you will identify that the object is symmetrical object, but the axis of symmetry appears in the top view because front and back are similar. Here in the front view, this is right side, here it is left side, top side and bottom side. Top bottom are not similar, so there must not be any axis of symmetry for front view horizontally. Also right side and left side are not similar, so there will be no axis of symmetry here. But in the top view, check here, right side and left side of the object are not similar, so there must not be any axis of symmetry here vertically. But this is front side, this is back side, and front and back are similar, so there must be axis of symmetry here. The object, if it is symmetrical object, then draw axis of symmetry properly. So this is how we have completed axis of symmetry. It's always better to draw axis of symmetry initially. Now let's proceed part by part. So let's complete this cylinder first. To draw the cylinder in orthographic views, remember, when cylinder is in its obvious position, that is axis perpendicular to one of the reference planes, then it appears a circle in a view, remaining two views a rectangle. Here axis of this cylinder is vertical. From top it appears a circle. So to draw that circle, we'll have to locate its center. First of all, center is on axis of symmetry. This is the axis of symmetry. From right side, this is right side. Along axis of symmetry, you should measure 18 millimeters. Draw center line. So this is how we have located center of the cylinder in the top view. Now complete the circle of radius 18 millimeter. So this is cylinder in the top view. It's hollow cylinder. It's hollow cylinder. So there is circular edge opening of the hole. Check the radius, it's 11 millimeter, take it in compass and draw the circle. Now cylinder appears a rectangle in the front view, and in the front view you get length of the cylinder. Length, that is horizontal dimension, in the top view is length. So project that length in the front view. And in the front view you get height. Height of the cylinder is 25, but that is to be measured from top. So measure height 25 millimeter and complete the rectangle. So this is how cylinder is ready in front view and top view. And the hole, project its horizontal dimension and it is through hole from top to bottom of the cylinder. Draw dotted lines. Okay. So where is this hole in the front view? So this rectangle. Remember, the hole has edge at the top, that circular edge at the top, and this edge appears horizontal and it coincides with edge of the cylinder. So this rectangle is dotted a rectangle and that is hole in the front view. Now when cylinder appears a rectangle in a view, then you should draw its axis. So we have drawn axis of cylinder or axis of the cylindrical hole. Now we should proceed for the second part of the object, that is base plate. So let's draw that base plate. Try to understand once again. In the top view, you get overall length of the base plate and width of the plate. Length horizontally and width vertically. What is length of this base plate? 12 plus 32 plus 12. That is 56 millimeters. Parallel to length. From left end, this is left side of the object, this is right side of the object. From left, parallel to length 56 and width is 75. So width 75 is already measured here. So 75 width vertically, 56 that is length of the plate horizontally, and will complete that rectangle. So 56 is length and width 75. So this is that rectangular box. in the top view. That is base plate in the top view. And in the front view, its length 56 will appear horizontally and height 18 millimeters that will appear vertically. And this is how measure 18 millimeter height vertically and complete the front view of the plate. So this plate is in the top view and also in the front view. So front view and top view of this plate, but there are smaller details in the plate. That is, there is rectangular slot here and there are two holes here. Let's continue with those smaller details now. This slot, from front, opening of the slot you will able to see. So draw this opening here. Measure 12 millimeters from left end, then 6 millimeters vertically, then 32 millimeters horizontally. Watch here, 32 millimeter distance given. Horizontally, this is length axis and length axis is horizontal in the front view, and then 6 millimeters edge. So this is how we have completed opening. But remember, it is not a hole, it is a slot. Hole always has a closed boundary. Slots doesn't have closed boundary. Check here, from bottom edges of this slot, corners of the slot, there is no edge. So this edge is to be trimmed out. So this is how we have completed the slot in the front view. In the top view, this slot appears a rectangle. Remember, watch here. From this corner of the slot, there is a small edge through the opening you can see running parallel to width. Watch here, this small edge here from the corner running parallel to width. And when depth of the slot is not given, we have assumed it through slot. So from all these corners of the slot, parallel to width, in the top view, parallel to width means vertical. Vertically, you will have to draw edges. From these four corners, there are edges, and those edges are parallel to width axis because slot runs from front to back. That is, parallel to width axis edges we are going to draw here, and width appears vertical in the top view. So from these corners, draw projectors and corresponding edges. Now these are edges of the same slot. Now if I ask you where is the slot in the top view, so show me this rectangle. This slot is of course at the bottom, so it is hidden from top. That is why we should draw hidden lines for the slot. So this is how we have completed the slot in front view and top view. Now there are two holes, circular edges of the hole. Circular opening of these two holes appear in the top view. So let's locate center first. 28 millimeters, parallel to length. In the top view, length horizontal. So from left side, parallel to length, you measure 28 millimeters and draw the center line for the circular hole. Now location of this circular hole from back and from front. So from front 15 millimeters. So of course front and back are similar. So from back also it is 15 millimeters. So measure 15 millimeters. This dimension 15 millimeter is parallel to width, and width is vertical in the top view. So we should measure it vertically in the top view. So this is how I have completed the center line, which is a parallel to length axis also. So after locating the center, complete the opening of the hole in the top view. Similarly on the front side also. So measure 15 millimeter, draw center line. Measure 28 millimeter, draw center line. And this is how we have completed the hole in the top view. Now project that hole in the front view. That is its horizontal dimension. Top view to front view, that is horizontal dimensions of particular detail you project by drawing end projectors. So this is how you draw end projectors, and this hole is in this portion of the object. So draw dotted lines. So this is how we have completed hole in the front view. Both the holes are there in the front view and they overlap in the front view because these holes are one behind the other when observer watches from front. Okay, when circular hole appears rectangle, its axis you are going to draw. So this is how I have completed the axis. So two major parts are over, and connecting these two major parts there is a thin plate of thickness 12 millimeters. So its larger surface appears in the front view, and in the top view the plate appears only a strip of thickness 12 millimeters. Of course this strip must be drawn in the top view between the end projectors, but its largest surface, that is shape of the plate, whatever it is, this shape appears in the front view. So how to draw plates? Largest surface, that is shape in a view, remaining two views are thin strips. So let's continue with this plate. 36 millimeters. From center, parallel to length. Length appears in the front view. So from center, that is axis of the cylinder, 36 millimeters, parallel to length I have measured. So this is how we have located this corner in the front view. Okay. Now draw that edge. So this edge is complete in the front view. Then this inclined edge of the shape. Watch here. It is from this corner to the extreme left top edge of the base plate. So top edge of the base plate is here. This edge appears a point in the front view. So this is how I have completed this edge of the object. And then this edge of the object. This edge of the plate, let's draw. It is from base of the cylinder to the base edge of the base plate. Watch that dotted edge is shown to make you understand that this edge meets at the bottom edge. So draw that edge at the bottom. So this is how we have completed the plate. Now draw end projectors of this plate. Watch this plate in the front view. Extreme right of the plate and extreme left of the plate. From these two extreme points, corners of the plate, we should draw projectors. These are called end projectors. And this is how we have completed. So from this point, projector. So this plate is from left edge of the base plate up to the cylinder. And this thickness is 12 millimeters. So from center line, measure 6 millimeters and 6 millimeters, 12 millimeters total, which is parallel to width. In the sense, in the top view, it should be measured vertically. In the top view, width should be vertical. Okay, and this is how we have completed the plate in the top view. But there are some minor mistakes or details involved here. Two visible edges don't intersect. So there is a correction needed here. And also, when two surfaces meet in one single plane, then there should not be edge in between those two surfaces. So here also, this top surface of the plate and top surface of the cylinder, these two surfaces are in one plane. So at the joint of these two surfaces, this edge must not be there. So corresponding corrections will do now. Also, this plate has a corner, sharp corner. Corner is formed by three edges. Where is this corner? In isometric view, check. Here is the corner. And corner is formed by three edges. Out of those three edges, two edges, this non-principal edge and this edge which is parallel to length axis. These two edges you can see in the front view. But the third edge, this edge, will appear in the top view. And that is why from corner, draw the projector and draw that edge in the top view. So this is edge in the top view. So against a corner, in opposite side view, there must be an edge. So from the corner, draw projector and complete that edge. Okay. Watch here. This edge, we have erased it or trimmed it. Of course, two visible edges don't intersect. So watch here, this edge, it is up to the plate. So here it is. Similar edge is on the back side, watch here, and it is up to the plate again. But one important thing is, from the top corner of the plate, there is an edge running parallel to width axis. Similarly, from this corner also, there is an edge. So that edge will appear here as hidden edge. So this dotted line is from this corner, edge from the corner. Now here watch. We should trim this portion. Because these surfaces are in one single plane. That's okay. But one very important thing. Similar circular edge is at the base of the cylinder also. Here it is. And this cylinder or circular edge is still there, but it is hidden from top. So its some portion will appear here. So don't forget to draw these hidden lines. This hidden line here, that is actually base edge of the cylinder. bottom edge of the cylinder, which is still there. Listen, at the top, surface of the plate meets surface of the cylinder at top tangentially, that is in one single plane. But lower surface of this plate and lower surface of the cylinder, they are not meeting tangentially. So this circular edge is intact. And its portion, hidden portion, we can see here. And then insert dimensions. You are asked to insert 6 dimensions. I have inserted here all given dimensions. Remember, nearest dimension line must be at least 6 millimeters away from the boundary. This is parallel dimensioning, 2 parallel dimension lines at least 6 millimeters away from each other. Then here, these are take care of all details of dimensioning. As far as possible, we don't insert dimensions in between the views, but here I have inserted, because it's always better to insert dimensions closer to particular feature. That is, this length is 32 millimeters. It's better to insert dimensions nearby this feature instead of drawing long extension lines and inserting somewhere too far from the particular detail. Also remember, this slot in the top view, it's hidden. So as far as possible, we avoid inserting dimensions for hidden detail. That is why 32 millimeter dimension I have not inserted here somewhere, because this particular slot is hidden in the top view. So try to understand all these details. Diameter for outer circle, diameter for inner circle, and there are 2 holes. Check how dimensions for the holes are given here. So this is how we have completed the drawing. We have used the first angle method of projection. So of course, front view above and top view below. If you draw this symbol, then you need not mention front view and top view here. Now let's read this problem. Pictorial view of a machine part is shown in following figure. Draw front view in the direction of arrow X and top view. The question was asked in Mumbai University, December 2017. Okay, focus on this diagram. First of all, we'll identify orientation of length, width and height in this diagram. These are our regular 3 axes. Vertical axis is of course height axis, and out of these 2 inclined axes at an angle 30 degrees, width axis is that axis which is parallel to this arrow X. So we are going to check width in this direction, height of course vertical, and length in this direction. Okay, let's check length of the object. Length, that is those dimensions which are parallel to length axis. So 60 millimeters we can see here at top. It is given distance from center to center. Extreme right edge is curved edge, extreme left edge is curved edge. So we'll have to check the radius of those curved edges. So center to center distance 60 millimeters is given. Radius here it is 18 millimeters. Radius here it is 18 millimeters. So 60 plus 18 plus 18, that is overall length from extreme right to extreme left. That is length of the object. It is 60 plus 18 plus 18. It is 96 millimeters. So we have identified length of the object. Now let's check height of the object. So 90 millimeter vertical dimension is given, but it is from base, from bottom of the object, but not up to top, but up to the center of the cylinder. And topmost edge is curved edge, so we'll have to add its radius. So it's 90 plus 18, 90 plus 18, that is total height of the object is 108 millimeters. So this is how we have found out height of the object. Now total width of the object, let's check it. 24 millimeter dimension parallel to width is given. This is from extreme front. So from front to back, complete width we are checking here. So 24. So this distance from front up to the surface, this edge of the plate, it is 24. And then add a 25. So 24 plus 25, that is 49. Now from extreme front, 36, that is cylinder's axis length. But that is not width of the object. It is axis length of the cylinder. Width is from extreme front end to extreme back end. So it is 24 plus 25, that is 49. This is how we have identified length of the object, height of the object and width of the object. If required, pause the video, check whether you have understood overall length, overall width and overall height of the object. And now let's proceed. So since we have identified overall dimensions of the object and we are asked to construct only front view and top view, let's start with front view rectangle. Always we start with front view rectangle, in which length horizontally, height vertically. So length 96 and height 108. Complete the rectangle. Rectangle of height 108 and length 96. Transfer that length in the top view. Project that length 96 in the top view. The other dimension appear in the top view is width vertically. And how much is that width? 49. So leave some space, approximately 20 millimeters, and then measure width 49 and complete the rectangle. So this rectangle, height 108, length 96 for front view, and this rectangle, length 96 horizontally, width 49 vertically, top view. Now check whether diagram is symmetrical. As I have told you that one glance is enough to know that whether object is symmetrical or not. This is not a symmetrical object. So there will be no any axis of symmetry for front view or top view. Okay. Now we'll start constructing shape part by part. So there are two cylinders I can see here which are connected by plates. So two cylinders at top, from front, this is front direction. That means in front view, these two cylinders will appear. These are hollow cylinders. So locate center. From top at distance 18 millimeter, that is the radius of the object, this center line which is parallel to length. So I am drawing that center line. This center line is parallel to length axis. Length appears horizontal in the front view. So from top, measure 18 millimeters, that is center is at distance 18 millimeter from top, and then draw the center line. Now measure 18 millimeters. From left, center is 18 millimeter. Also from right, center is 18 millimeters. So locate those centers first. Similarly here from right 18 millimeters, and I have drawn the center lines. So this is how we have located centers of these two circular edges. So this is how complete circles, and there are holes also. So draw concentric circles. So inner circles represent opening of these two holes. When depth of holes not given, we should assume through holes. So these holes are through holes. But right now in the front view, we just can see opening of the hole. Now this two cylinders will appear rectangles in the top view. And third dimension for the cylinders. For example, this cylinder. This is length of the cylinder, width of the cylinder. This is the height of the cylinder, in fact. And width of the cylinder is 30. Width in the sense, dimension of the cylinder parallel to width axis. That will appear vertical in the top view. So this 36 millimeter dimension will appear vertical. So from front, you should measure 36 vertically. So project horizontal dimension, that is, draw end projectors of the cylinder. Measure 36 from front, complete the rectangle. So this is how this cylinder, that is this cylinder, is in the top view, which appears rectangle. In front view circle, in the top view rectangle, in the side view rectangle. But in this question, we are not asked to draw side view. Okay, similarly this cylinder we are completing. Then there are holes in the cylinder. So for the holes, we should draw dotted lines. So nothing new here. So this is how we have completed the two cylinders. Now where cylinder appears a rectangle in that view, we should draw axis of the cylinder. So I have drawn these two axes of each cylinder. So cylinders are over. Now let's focus on these two plates. This plate, which has certain shape. Okay, so we'll try to construct these two plates. This plate, which is vertical plate, it's this particular shape will appear in the front view. But this plate, which is 12 mm thick, it will appear as thin strip of thickness 12 mm measured vertically. So this top edge is tangent to both the circles. Then this bottom edge tangent to both the circles. And here at distance 12 mm from the lower tangent, from this lower tangent, vertically measure 12 mm and draw a thin line. Don't make that line dark at this stage because there are curved edges here of radius 4 mm approximately. If radius of such small curves are not given, we can assume that radius. Okay, so we'll draw these two curved edges, these small curved edges here. Watch. To draw such smaller curves, you may use a pro circle. So draw those curved edges and then the portion of the edge you should make dark. The portion which appears as horizontal edge you should make dark. So this is how we have completed this particular edge, which is 12 mm from lower tangent to the two circles. Now, yet it is not complete. When this plate is connected to the cylinder, check the joint, that is this line, and here this curved line. Check the joints. Here, these surfaces, circular surface, this ring-like surface of cylinder, this front surface, ring-like surface of the cylinder, and this strip-like surface, they are in one single plane. So these two lines should disappear here. Now let's draw this cylinder. This plate. This plate in the top view. Nothing to think. This plate appears between its end projectors. So focus on right end of this plate, left end of this plate and draw end projectors. Between these end projectors, we are going to draw 12 mm thick strip. So here it is. So in front view shape, so in top view, it is rectangular strip between end projectors. But there is a mistake here. Two visible edges don't intersect. And one more thing. These two edges here, what you are watching here, are not here. The reason is, watch the three-dimensional view. The reason is this strip-like surface of the plate meets curved surfaces tangentially. And that is why there are no sharp edges here at this end and at this end, where that surface of the surface of the plate meets curved surface. At that joint, there is no sharp edge. So these two edges must not be there. So I have erased those two edges. And watch these small curves here. These small curves, diagrammatical representation that indicates tangential joint between two surfaces. So when a flat surface meets curved surface tangentially, then in orthographic views, this is how we denote that tangential joint. And that edge, sharp edge, which I erased here just now, is replaced by this curve, indicating it is not a sharp edge here, but it is tangential joint. So this is how we have corrected the joints here. Now one more thing. These two edges are also to be erased. I have erased edges here, check here and here also. So necessary correction you will have to do. Remember, when two surfaces meet in one single plane, then boundary between the two surfaces you will have to trim out. So curved surface of the cylinder. Remember, this is this dark line. Can you see here? This dark line. This is a boundary generator of the cylinder. So cylinder has a 36 mm long boundary generator at extreme end. Yes. But inside here, the boundary generator is not 36 mm long. The curved surface is not 36 mm. It is 36 minus 12. That is why this portion is to be erased. Remember this, two visible edges intersecting, that suggests you some correction. And remember, on the boundary generator, when there is a joint, on boundary generator of a cylinder, if joint appears, then boundary of the cylinder inside the joint is to be erased. Now this horizontal plate in the top view, you will have to complete by drawing a dark line here. So this surface what you are watching here, horizontal surface, you can see here. So this is how the upper portion is complete. Now this lower part, let's complete. Check here. I've just separated from the upper portion that lower portion. Here there is a hole. The smaller detailed holes and slot we draw afterwards. Now how to complete views of this? So this F-like shape, this F shape, inverted letter F shape, it appears in the side view. So in front view and in top view, this object appears a rectangle. So let's complete front view of this object. Which two dimensions you can see in the front view? Height and length. So check what is height of this object. This object is attached to the upper portion from lower side. So 18 millimeter from 90, you subtract 18 millimeters, that is radius of this circle. So it's 72 millimeter, that is height of this. Of course, you need not measure that 70 millimeters. Extreme bottom to the upper portion, you can draw those lines. And length of this, the length in the sense parallel to length dimension of this object is 60 millimeters. So 60 millimeter length and 72 millimeters height. This portion is complete. When you measure 72 millimeters, the part will get connected with the upper portion. So this rectangle is front view of this portion. But of course not yet complete. We have just measured height and length. In the top view, the same portion will come. Length 60 millimeter we have already measured here. 60 millimeter length we have already measured here. Now project it downwards. And width of the object is 25, but that is from extreme back side. So from back 25 you should measure. And this is how we have completed the rectangle in the top view. Now this is very important to understand. Check carefully what I am telling you. Front view of the lower portion of the object, this portion of the object. Front view, length 60, height 72. This is front view. And front view of upper portion, there is no overlap here. Front view of lower portion, front view of upper portion, no overlap. But in this case, top view of upper portion and top view of that lower portion, there is certain overlap. The box, this F-shaped portion we are drawing here is under the upper portion, and the portion which is overlapping, that is hidden. So when you complete this rectangle, you will have to take care of that. So watch here, this portion we have drawn visible, which is not overlap, and this portion is hidden. So where is this part in the top view? So again show me this complete rectangle. Each and every part in each and every view you must be able to identify. Then only you will able to read orthographic views properly, or you will able to construct orthographic views properly. This is that lower portion. Okay, now smaller details. Let's continue with the smaller details. A corner is formed by three edges. Here, from each of these corners, watch these corners. There are edges you can see running from right side to left side. Watch here, these edges are running from right side to left side. So right side to left side, that is parallel to length. So we are going to draw those edges here. Measure 12 millimeters from bottom. Draw that hidden line. From front, these edges are hidden. 25 millimeters I have measured. Draw the hidden line. And 12 millimeters again I have measured and hidden line. These edges are parallel to length axis. Okay. So this is how front view except this whole front view of the object is complete here. Now in the top view, same three edges. So these edges we are drawing here in the top view will overlap with already drawn edges, and that is why these three edges or the edges from these corners will not appear in the top view. Not appear in the sense they are already overlapped in the earlier drawn edges. Okay, now let's complete this hole here. This hole has certain shape, so we'll have to construct the shape very carefully. So measure 25 mm vertically and draw the center line which is parallel to length axis. So 25 mm vertically I have measured, and this center line which is parallel to length axis. Now watch this dimension, 22 mm parallel to length. So measure 22 mm parallel to length and draw the first center line here, which is vertical center line. And then at distance 9 mm, watch here, 9 mm. At distance 9 mm to be measured parallel to length again. One more center line. So this is how we have drawn those two center lines which we can see here to draw those curved edges, and the radius of each curved edge is 8 mm. So draw those semicircular edges here with radius 8 mm. And then complete the shape by small principal edges here, parallel to length edges. So this whole opening in the front view is complete. Now draw end projectors from the hole. This hole is in this 12 mm thick part only. 12 mm thick part only. So draw corresponding dotted line. So this is how that hole is complete in the top view. One more part is remaining, that is this triangular plate. I have separated the triangular plate. Now its triangular largest surface, that is triangular portion, is visible in the side view. We are not asked to draw side view here, but in the front and in the top, since it is a plate, it will appear a thin strip showing its thickness. Thickness is 12 mm, which is parallel to length axis. So thickness 12 mm parallel to length to be measured here. In the front view, it is a strip from bottom, and in the top view, it is again a strip, but it is under the upper portion of the object. So this strip is hidden in the top view. So check, I am drawing this triangular plate in the front view. That's all. It is rectangular strip of thickness 12 mm. So measure 12 mm thickness of the plate which appears parallel to length axis, and in front view length axis is horizontal. So this is how I have completed the triangular plate in the front view. Now same plate in the top view, draw end projectors and up to this part. Watch here, this rectangle is the same triangular plate in the top view. So even if there are so many hidden lines, you are not confused. You know that these two hidden lines here for the hole, this hidden rectangle is for the triangular plate, and these two hidden lines for the circular hole, this oval shaped hole. So if such orthographic views are in front of you, so take help of end projectors. Imagine, visualize end projectors to read the orthographic views. Right now we are not reading orthographic views, we are drawing orthographic views from given isometric view. Okay, let's proceed now. So what next? Dimensions. So insert all given dimensions. Of course, in exam, if you are asked to insert 6 dimensions, you should insert 6 dimensions. But here I have inserted all given dimensions. And which method of projection we have used here? First angle method of projection. Okay. Remember this again. In between the views, as far as possible, we don't insert dimensions. But as I have told you, the given dimensions must be nearer to the corresponding feature. So instead of drawing very long extension lines, it's better to insert these dimensions in between the views. Insert for entire hole diameter, and for portion of a circle radius. Take care of that. Enough space between parallel dimension lines. So follow all the rules of dimensioning, complete the dimension, and your drawing will be perfect. So thank you for watching the video. We'll meet soon in my next video. We'll continue with orthographic projections. In next video, we'll solve problems from latest university question papers. Till then, bye bye. Take care.